So welcome everyone. And so it's my pleasure to introduce for today's ETM Speaker Series event, Dr. Gerry Williams. So Dr. Gerry Williams, I've known him since before I first arrived in PSU in 1995. I met him before I started at PSU when I was interviewing even for the position, and he was a PhD student at the time. When I came here, he ended up working with me then, studying construction productivity, and that's become his passion. And he has started a company that does consulting in areas related to this and construction litigation. And so it's an interesting story to hear about a very detailed aspect of construction productivity. And while perhaps some of you that are electrical engineers in here may not think too much about drywall or gypsum wallboard productivity, it affects all of us every day. I've got it right behind me here. Construction makes up about 10% of the world or the US economy. And these components, the walls and other things, make up approximately 10% of that. And so if we can understand how to improve productivity and operations in something that is 1% of an overall economy, we can have big impacts. And so Dr. Williams has been a leader here. He's been doing a series of ongoing projects over time, and he's going to give us information, talk about his research here. And so without further ado, take it away, Dr. Williams.
Hi, how you guys doing today? Hopefully well. So let me back up a little bit and give you a little bit of background. And that is that Dr. Anderson and I actually did a study on impacts of productivity in metal stud framing. Began in 2006, and we published it in 2009. It was significantly, it was essentially a lot of the same stuff, but it was significantly different in that we had, the world has changed a lot between 2009 and 2022 when we started this study. And actually, I think we started in 2021. Some of the main differences were that we actually had to hire a research assistant to go out into the field and collect the data themselves and go to contractor after contractor after contractor. And it was a very, took a lot of time. And it took us basically most of the time, because I think we wrote the report in about 4 months. You know, it seemed to me it came out pretty quick. Once the analysis was being done, we pounded it out fairly quickly. So this is an update. The first report, and I want to get to kind of some of the differences between them, but one of them was that we actually did this first report, and we asked questions that didn't have any context, so to speak. In other words, we'd say, rating on a scale of 0 to 4, what was the level of impact? And in this study, and I think I'll pull up that slide in a minute. If I just click on this, will that change that? No. Oh, I know. So I've got to go back to, I guess I'd have to go back to screen share or share. Well, let's go through a little bit here. So let me just say, one of the things that was really helped us along, I mean, we started this in September of 2021, and by, I think, February of 2022, so 5 months, we had collected 255 projects using data collected online by something called SurveyMonkey, which was managed by the Northwest Wall and Ceiling Bureau. The factors that we investigated, the descriptions of the impact, were generated by Neil O'Connor, who was one of the board members for NWCB and SWACCA. And then I'll let you know, okay, SWACCA is the Signatory Wall and Ceiling Contractors of America, meaning that they're all union contractors. And NWCB is a member of SWCCA, and it stands for Northwest Wall and Ceiling Bureau. We set up a lot of things to look at. We actually ended up spending really only identifying hanging or metal stud framing, hanging, drywall, taping, and finishing, because the other trades that we looked at didn't generate enough responses. Okay, so now. We did collect a lot of data that hasn't been analyzed yet. That's of no real interest to you, I imagine. But we did find some of these baseline impacts. And I want to say that the one that we used before was, we started out with 35 variables, which was way too many variables. And we came back with another study. It wasn't really a study, it was a tool where we reduced that 35 down to 18. And here we have, I think, 18 or 19 variables. And some of them are the same, but some of them are different from what we had in the NWCB study. So what this shows us is the different responses. And I want to go over it. Tim, can I switch over to another program? I want to pull up the PDF of the data collection.
So yes, you can turn off share screen and then share the other screen. So
new share.
Right. And you should be able to go back over to the other one.
Are you seeing what I'm saying? Or what are you seeing?
Yes, now we're seeing a PDF. It looks like a view survey.
Okay, so this is the actual PDF that we used, that was the data collection instrument. And a lot of this stuff, I mean, there are some of the things that are on here that the contractors wanted, which were really, I didn't think we should have. Like, was the project a good project, an average project, or a bad project? And the reason for asking that is because they wanted to kind of have a balanced response. But I want to skip down. I mean, this is just data collection stuff. But what I really want to show you is when I get down here. So just for an example, you can see we've got five different responses. And in the last time we just said, rank it between 0 and 4 or 1 and 5, whatever. But without any context. So this time what we did is we started this with a Finishing Contractors Association study that we did on painting, but where we actually describe what the response would be. So in terms of the overall documents, rate the quality of the plans and specifications relative to your scope of work. So the first one is response, which would be a 1 in this survey, is standard of the industry, requires minimal results for requests for information, RFIs, if you know what that is, a request for information from the designer. A 2 was could not be built without some direction of the designer. Number 3 was required weekly RFIs to execute your scope of work. Number 4 is almost daily RFIs, and I can't read the 5th one. Can you read that? You're muted.
Yeah, final project
different from original design documents.
I got a column of stuff here hiding my last little bit. So you can see what we're trying to do is we're trying to kind of really let the people who are answering the question know what we think, some way to give it context in order to let them, the intent really, what we found out is when we give an explanation, we can reduce the amount of variance in each of our responses. And so what happened before was that most contractors, if they have a bad job, they think that's just like the worst job in the entire planet. And it may be really a 3 or a 4, but they want to give it a 5. And when they do that, it skews the result, because they may not have had, maybe they had a 10% impact to productivity, but they're saying this is a Hurricane Katrina event, and it's really not. So we want, giving them that context made it. Okay, I'm back to the one I had before. You see that? Okay, so what this is a correlation matrix, and it basically, it takes all of the variables, responses that we received, and then compares them against all of the others. And we do this because we have a fair amount of intercorrelation between the variables. And what that means is that sometimes some of the variables are essentially measuring the same impact as the other variables. And so this will become important when we get down a little bit further in this presentation when I talk about combining, because we wanted to both show how these are correlated, but also and what the impacts are. But we also wanted to show, if we could, if you have a combination of 2 or more variables, would that improve or make it better explain the impact to productivity? So this is basically, I show you this because these values are significantly, I think they're significantly higher than what we had in the first run. I mean, we made all of our variables were statistically significant that we chose. I believe that's true in the first go around, but you can see, I mean, some of these are like 6.8 to the times 10 to the negative 9th. I mean, it's pretty incredible. We only had a couple that were not statistically significant at the 0.05 level. And I would have expected that these ones that didn't make the cut would probably not make the cut. But the contractors wanted us to include it, so we included them. But owner supplied materials for drywall, and take another step back. Does everybody have any idea, or does everybody understand what we're talking about when we say drywall contractors or drywall trade? You know, it's putting up metal stud framing, hanging gyp board, and then putting tape and finish and sand the gyp board when it's installed. So there's really, you know, a lot of the contractors felt like, well, we put windows or relights. A relight is essentially a window into an office space. And so you can see from the hall into the office, as opposed to a window, which would be from the office to the outside. And so sometimes those are owner supplied things, but that's not really a huge impact. And since you're doing mostly work inside the building, by the time you get to hanging drywall, you've already got the framing up, so the building ought to be fairly enclosed. And so weather shouldn't be a factor, and we see it wasn't highly statistically significant. Also didn't find that work stoppages, again, owner supplied and owner directed, didn't make the cut. And pretty much the same is true for taping and finishing. And taping and finishing is kind of special because it's the last thing you do. And so there shouldn't be much in front of you at that point. And that's kind of reflected in the values we received. And you see something that says base impact. So that is the baseline linear correlation. correlation, but it's a reduction. Anyway, it's the baseline for if we have a 0, 1, 2, 3, and 4, you multiply that number by the base impact to get the expected average impact for that problem. So you can see the first one says on framing, says construction documents, and I just went through the responses for construction documents, and you can see it's 12.31% with a p-value of 6.8 times 10 to the negative ninth. So if you have a 4 on that, then your expected impact, average impact, would be 48%. So that's a pretty high, that's a pretty big impact. Okay, where'd I go? Oops. Okay, so what we did then, as I said, we wanted to look at what would combinations look like. And so if it's, again, you can see the baseline, and then, so the first one, construction documents compared with construction documents, that's gonna be blank. Construction documents including overzealous inspections bumps it from 12.31 to 14.59%. And so, and you can see over the key at the right, that combination is statistically significant. Now, we get to a bunch of these combinations where they're not as highly significant. Now, if this was a research project and we were doing this for the purposes of publishing a paper in a respected journal or whatever, we would eliminate anything that has color on it in here. But we take a little bit different approach for an industry application. And that approach is that if you think about in the law, in criminal law, there is a presumption that it's almost no doubt, right? But in the civil law, it's more likely than not that you have had this problem or committed this crime or did this injury. So from an industry standpoint, we kind of look at it more like, well, we know that if we have bad documents and other things, or if we know we have problems with access to the job site and we have bad documents, that's statistically significant. But if we have access to the job site and weather, we know that there's probably some impact, but it's not highly statistically significant. But it's more likely than not it's going to be an impact. And so we're including these more likely than not in the industry study that we would not include if it were an academic study. So hopefully everybody understands the difference. So then what we did is we took those baseline impacts and subtracted out the combination. So again, we have the baseline at 12.31%, and then we have a marginal impact increase if they have overzealous inspection of 2.25%. Now, the reason that we do this is because there may be a situation where they're not the same. So let's say the baseline impact for construction documents is a 3, but overzealous inspection is just a 2, or the other way around. We can calculate our impact, total impact, expected impact, by applying different numbers or levels to each of the 2. So I've just kind of explained what those mean. I'll go on. Now, the hanging drywall, you'll see there's not very many of the combinations, at least nowhere near the number of combinations that are statistically significant compared with the framing. And I can't really explain why that's the case. It's just what we found. And this again is the baseline with the marginal impacts for the same purpose of calculating the difference. And one of the things I mentioned, so let's say we have two different impacts for, again, let's go back to this overzealous inspection and construction documents, which is 3. So more likely, you're gonna want to do the combination that gets you the biggest bang for the buck. And so you may put your emphasis on one more than the other to get the largest impact. Because what we're trying to do is we're trying to get a means for contractors to be able to get money, essentially, change orders for impacts to productivity that are beyond the scope of their work. So we want to look at how this compares to our previous study. And so the previous baseline impacts, the 2014 NWCB user guide, are given on the left-hand side for framing. And you can see that where they are the same, or where the factors are essentially the same, like quality of design documents, 12.1 in this study, 12.31 in our current one. Owner interference, here is owner directed here. I think that the owner interference here really is overzealous inspection. And so for the most part, our impacts calculated higher, and they were the spread of the data was much better. The linear regressions, the R-squareds, were significantly greater than what we had in the first section. And that makes a lot of sense, because when you give somebody an explanation of what a 3 means, or as opposed to what a 5 means, then hopefully they're ratcheting it back and saying, oh, well, this is really only a 3 or a 4, not a 5 or a 6. Oops. So for hanging of drywall, we see similar results that we did in framing. Congestion went from 6.1 to 10.21. Fragmentation went from 6.63 to 9.21. So those are significant increases, because if you have a 4, that one goes from 24% to 40, and that's a pretty significant jump in your impact. Congestion 4.56 to 11.41 and for taping and finishing, and fragmentation. And we found generally fragmentation fragmentation and congestion are the two biggest drags on productivity. And fragmentation in the framing side, where we have congestion, work fragmentation 9.2 went up to 12.1. So they're still the biggest impacts, but they jumped up even more. So let me see. We did another study for the Finishing Contractors Association where we did that same thing in terms of trying to give them something to base their scoring on. And you can see that for taping and finishing, and the FCA was just painting, taping, and finishing. So went from 8.6 to 11.41 and 8.0 to 9.03. So we're getting better at how we get at the productivity, or how to get the correct information out of people, which is kind of our real intent here. And really the purpose, not necessarily of this presentation, but the next thing that we're working on doing, putting together a more academic paper on this new update, is really to focus on the change in how we went about collecting the information really gave us a boost in how our outcomes were, and how it, we think, better reflects the actual productivity that you see. And you know, for you guys that are still students, you know, and if you do a study like this or something like similar, I would certainly recommend that you take out both the bias of the individual who's making the response, but also give them, you know, a hand in how to really measure the impact or whatever it is that you're trying to measure, and do it by a method similar to this. I mean, I don't think it's anything that we did that is, you know, like groundbreaking, but it's I do think that it shows an impact. I think it was a lot better, and I think that this tool that we use, the SurveyMonkey tool, made it a lot easier for the contractors. The unfortunate thing about it was that the thing was really long, and because the contractors wanted to really explore every little detail that they could, and they also wanted to explore other trades. And so, because in some parts of the country, not so much here, but in some parts of the country, the drywall contractors also do the painting. And the reason for doing that is that then they control the entire interior finishes part of their wall. You know, putting it up, putting the drywall on it, taping and finishing, sanding, painting, and then they have that whole package. That doesn't happen so much around here, but they wanted to add it to us. And I think we got a handful of responses where they actually graded the painting. So, so again, you know, some of the conclusions and concerns that we have believe that generally very highly statistically significant base impacts was due to the way we collected the data. I've kind of covered that about 3 times now. There is a high degree of collinearity in the data, which makes combining variables difficult, but not impossible, not in all cases. Baseline impacts are higher consistently, and probably a better byproduct because of the questions we asked. And there are some concerns about the baseline impact at 1.0. We have run new regressions on all the rank. Oh, never mind about that. That actually is not a concern we have. The next step is to rerun a significant amount of the data using 0 to 4 scales. We've already done that. Use cluster analysis to determine if there are any significant differences between SWACA member groups. Now, the NWCB study that we did in 2009, that we published in 2009, only had contractors from Oregon, Washington, British Columbia, I think one from Idaho, and a large number from Northern California, and none from Southern California, and no place else. SWACA is a nationwide organization, and so we received inputs, and this was one of the things that kind of drove SWACA to want to redo this study, was to look at it on a larger base, so that they didn't get criticized using this NWCB guide if they were in Texas or if they were in Pennsylvania. And so now what we've done is we've spread the base all across the country. But what we haven't done yet is to look at, well, is there a significant difference between the contractors in Illinois and the contractors in California? That's one of the things that we need to do. There are, okay, so the project size varies, as you didn't see, but I can tell you that there are some contractors that used very small number of, not small number of projects, but projects that maybe went from $200,000. And then we've got projects that are 10, 20 million. So it's possible, and we need to look at those in terms of whether or not they're outliers in their scoring ranges. to see if the linear regressions that are calculating the base impacts are significantly impacted by size. So then I think, well, the next deal is replacing the existing NWCB user guide with a new NWCB SWACA user guide, which we will have to present at the May 2023 Wall and Ceiling Bureau conference and trade show. This next comment really is immaterial to you, but my graduate student at Oregon State who helped me with this project is likely to use some or all of this in his doctoral dissertation work. So now, having said that, questions? You are muted.
Yep.
There you go.
So Chip is always great for kicking off our first questions. So feel free, Chip.
Well, yeah, I'll take the easiest one first. How many surveys were sent out, and how many responses did you receive for those SurveyMonkey things?
So there were no actual surveys sent out. There was simply a link to the SurveyMonkey that was housed wherever on the cloud someplace, but it was put together by Tina up in Seattle for the NWCB. And so it was being, it's difficult to say, if you got a link sent to you with an invitation from the president of SWACA to put together three or four projects for review or for inclusion in this, how many were sent out? There were probably a couple of hundred contractors that were solicited. And I don't know the number off the top of my head, how many contractors actually did supply us with responses. And that was another interesting thing. In the first go around in 2009, we got about 50% of our responses from one contractor. That one contractor had 20 offices around the country and had offices in Seattle, Vancouver, Seattle, Portland, Spokane, several in the Bay Area, and one in Sacramento. So that was kind of one of the things about that survey that we were concerned if we were just really reflecting one subcontractor's experience.
Great, thank you.
How many projects were unimpacted? Did you see were kind of a golden perfect project with any?
There were a number of, they, again, not my advice, but they decided to ask, well, is this a good project, a bad project, an okay project, whatever. And so they encouraged them to get us some good projects. And I think that was helpful also in getting the bigger impacts, bigger rate of impact, because I think that in our first survey, we saw very few that were zeros.
And this time you saw zeros.
Yeah, we saw zeros. And then we also didn't see the extreme, fives, so many fives that with low impacts. And that's what drags down our impact to productivity, is when you have a bunch of guys that are saying, oh, this is like the worst project on the planet. And you look at it and goes, yeah, but your impact was only 7%.
Yeah, and so one of the improvements from the previous study is the previous study seemed to suffer from more of a selection bias of people thinking of their worst projects for submitting as compared to a more representative sample or selection of possible projects.
Yeah, I'm hoping that's the case.
One key assumption, and there's probably not a good way of working around it other than to accept it and use it, is the assumption that the interpretation is a linear scale, that interval scale from 0 to 5 for a level of impact on each of those things, that the words used to describe those have a consistent interpretation of the interval meaning. Because when you convert it to a number from 0 to 5, you're saying that that it has the same impact going from 0 to 1 as it does going from 4 to 5.
Right. And that's not really probably true. And I think the descriptions probably bear that out. And I'm not really sure how much that works against us. I would say, I guess that we were trying to discourage people from using 5s.
Yeah.
You know?
Well,
and we had a lot fewer.
You can look at plots of essentially a graph of those variables over the 0 to 5 scale and see what your residuals are like. For either plotting for productivity for each or the error term, and if you see consistent patterns where it slopes up really fast on the high end side, that would speak to a nonlinear intervals, for example. And so there's a variety of ways of accommodating it, but it's a common assumption to just convert it to an ordinal kind of Likert scaled thing and accept that as a simplifying numerical assumption.
Right. They weren't given a 1 to 5, so to speak. They were actually just, if we can go back, I'll share this.
They were given the words. Yeah.
And here it is. So that down here. So all they would see is this, and then they would, click on it and go to the next set of questions. And, and then they click on here. And so we had to actually go back, and Olu had to go back, actually, not me. Olu had to go back and convert all of those to 1s, 2s, 3s, and 4s.
Yep.
0, 1, 2, and 3, 4.
So, and what was at the very top introductory word or sentence said something about on a scale of 1 to 5?
Yeah, I don't know why they said that, and then we turned out and never used that.
Yeah.
I mean, it was, but then we went back, or Olu went back and converted all these into numbers, which was, not the most fun thing for him to do. But we got a lot more, I think, numbers that were a lot more on the lower end side than the 4s and 5s. The majority were 1s, 2s, and 3s.
So and so this is interesting then also from the idea of a PhD student project that will be a part of his dissertation. So are you on the dissertation committee then as an outside member?
I haven't been asked.
Oh, okay.
So, and I don't know what OSU's policy is about that. Who knows?
Yep. Okay. So, good. Are there other questions? I'm not seeing anything else in the chat.
Dr. Anderson, I'd ask one more if you let me.
Go for it, Chip.
Right. So there were a couple of columns about owner supplied and owner directed issues, and they seem to have lots of red and bad colors. Does that indicate that the owner supplied or owner directed projects had issues?
No, the red indicates that they're not statistically significant. And
okay.
And so what it means, and if we go back to the very first one, the table that I was showing you that showed that the different variables that weren't even statistically significant when they were when the regression was done on just them, as opposed to a combination of that one with something else. And so it's it didn't surprise me that it wasn't a problem, but contractors wanted to include it, and they did, and they got what they paid for.
Thank you.
Yeah, you notice, you look at this, if I still have the PDF up, I mean, the PDF is 48 pages long. I mean, I'm really an advocate for brevity. And I think if you could stick to like just 8 variables, we'd be better off than 10 or 12.
48-page long survey for a single project.
Yeah. But the thing is that when you get down, so once you get through the 3 major things, framing, hanging, and taping and finishing, it's then they bring up the next thing, and you can pick, and it's like painting. And if you're not going to do painting or anything else, you can stop at that point and say hit return. I'm not sure how many pages down that is, but I can scroll down. So there's a drywall.
Did you try and time how long it would take someone to fill out the survey if they were kind of doing it with care?
It took me about 15 minutes to do the framing, taping, and or framing, hanging, and taping. When I the first time through, I didn't go. I'm showing you here the painting. I didn't include that in my response. I think that someone told me that the first time they went through it was 30 minutes, and then after that it was took fewer or shorter, which I kind of expect.
Yeah.
But you can see here, so painting starts at page 15. So really, you're only going to go through 15 pages of that.
Mm-hmm.
And then most people at that point are just going to say, okay, we're not doing this anymore. So off they go. And I can't remember all of the things they had, but they're like painting and I think there was installing a door frames and a whole bunch of stuff that people just kind of said, I'm not going to do that.
Yep. Okay.
But
So-
most of them too, you see construction documents here for taping and finishing, and they're the same same responses as we had for framing. So that also helps you kind of move along through it.
Okay. Well, very good. I'm looking forward to seeing where the work continues to go. And I know that we're going to have a follow-up meeting at some point talking more about data analysis. So I'm looking forward to hearing more about it. Thank you. And we had a nice large audience, 29 people. So with
Wow.
the Zooms, oftentimes it is people are often not asking a lot of questions just from a dialogue perspective, but it is an interesting and important topic. When we look at how important the construction industry is, if we can learn better how to help these things go smoothly and go well, hopefully they can avoid running into problems afterwards. And so, great.
Yeah, well, of course, the guys that paid for this, they want to use it to get bigger change orders.
Oh, yeah.
But if the initial guide that we put together, my advice was always to hand it out to the general contractors. Show them what the impacts are.
Yep.
And
Well,
of course,
and that can help out for people really appreciating how impactful late changes are to projects. I mean, a lot of the problems of from owners often come in and show up later, as you saw showed. So,
Well, I'm working on this Nike claim, and it's public information, so I'm not telling you anything that you can't find out by reading the newspaper. But subcontractors on Nike merchandising and headquarters building have filed $120 million in claims. I mean, $120 million, that's the lien amount for that. I mean, it's incredible. But the problem was the project became so congested and so fragmented. So it's the same kind of stuff we see even on, smaller projects. And that's almost $1 billion building. But, we show this on small projects or medium-sized projects or large projects, but then these humongous projects, and I can't go into tell you why they've filed those, because that would be a secret. But mostly it's because of work fragmentation brought on by issues with the design, issues with the designer, issues with the general contractor, moving people around, and it can be an enormous increase in cost. There are a lot of subcontractors on that project that may not survive unless they can get paid.
Yep. Yes, Chip threw in the chat a PBS Nova London Supertunnel, the stories of construction projects that run late and cost extra are legendary. So, yep. Okay, great. Well, we're right at getting close to time. So thank you very much. This has been great. And so thank you, Dr. Williams.